All right, let's continue our repo carry adder design. So this repo carry adder design we're going to use to our in our new project that is called add and sub. So let's create a new project. Next, this is the folder of our new project, add sub, and then we're going to give name add sub. So make sure that you save you create a new folder. Mine is add sub. Next, empty project, and then we need to add the files that we're gonna use in our new project. So we're gonna use the full adder here. So it was in basic that we designed a full adder. So if you didn't convert it to Verilog file, you need to have Verilog file. So we're gonna use full adder, and then we must have our half adder too, because full adder is built on half adder. So you need those two files open. The next, and then we will choose our board, the last one here, and then the simulation is minus extra Intel FPGA. Next, finish. Now we're gonna create a new Verilog file. So go to new Verilog file, and then we need to save this Verilog file as the name that we're gonna give. Mine is ripple carry adder. So we're gonna design a ripple carry adder that is parameterized. That means if you want to add 2 bits, 3 bits to 16 or 32, so we need to call like n bit ripple carry adder RCA. Save it. Now let's design this file. So we're gonna design the same way as we talk about when we talk about here the design of this ripple carry adder. So on this ripple carry adder we have the inputs variable that are the x and the y, and we have a carry in that is the input, and we have output that are sums from sum 0 to sum 3. So there are 4-bit sum and 4 bit of each x and y, and single bit of carry in and a carry out that is also single bit. And then we have internal wires that are this carry. So let's continue designing this folder. So we're gonna give the module name. So it must be the same as our file here, otherwise we're gonna get an error. So it's gonna be n bit ripple carry adder RCA, and the inputs as we have shown it, we have a carry in. So that is our first input, and we have x, that is our input, y, and sum, that is our output, and carry out. And then we need to close this module, end module. Now since we said this is going to be n bit, that is parameterized, so we need a parameter we'll give it name n. So now it's 4 bits, so we want to give it 4. And input, so we need to declare our input. So we have input carry in, and then we have input, that is 4 bits. So this must be a vector of 4 bits, so we need to use n minus 1. So from 3 to 0, that is vector, so it's going to be 4 bits of x and y. And then we have so those are input, 3 inputs, and then we have output. So it's a vector 2, n minus 1. So it's 3 is 4 bit again, that is s for the sum. And then we have another output. So this one is for the carry out. So to display the carry out bit. And then this is a single bit, same as carry in. And then we have those wire we have discussed. Wire, well, I'm gonna give it 5 bits. See, so that's our internal wires. And then since we're gonna use something called generate, we need to declare an integer variable that is only positive inside this generate block. So this is gonna use the what called genvar e, and then we're gonna assign the carry in. So the carry in is usually gonna be on this the first vector of this C. So that's gonna be our carry in. And then we have a carry out, so we need to assign the carry out to. So this is the output. So carry out, this is output. So we give it the last y of the carry ins. So 4. So here this is our carry in. So if we put something here, it's gonna change on this wire here, the first vector. But here the carry out is just the last position of the vector is gonna be assigned to the carry out. Let's generate this the full adders. So we're gonna use this generate block. Let's close this generate. So generating use when you have the for loop. So this I from 0 to when I is less than or equal to n minus 1, also from 3 to, and then to 4. So we must add this I to e plus 1. And then let's close this. So we are now done with our for loop. So but we need to get something called begin. So, and then we're gonna give the name of our instantiations of the full adders. So we can just say this is full adder, RCAs. So that's the name we're gonna give this this generate block. So now we need to instantiate our model now. That is the full adder. So we need to make sure that how it's written the same way as we have it. So let's just go back to basic and open this full adder so we don't do a mistake. So you can see in our full adders it named like this full adder, and then it have the carry in, and so that those are the inputs, and output are first is sum and carry out. So we need to insert it as full adder, the same as it was written there. And then you can see, for example, model. So this is going to iterate 4 times, and then the first was carry in. So then this one so it's going to be this C, E, and our first the X. So we're going to sum the X, all XE, and we're going to sum all the YE. So, and then we have, let me see, it is sum and carry out. So our first position is sum, so it's S, E, and the carry. So the carry now, each carry we're gonna sum is the previous the future one, so it must be I plus 1 when we are summing. So like that, and then let's try to save it and save this one as top level entry and try to analyze and synthesize. Yeah, now we have an error here, but I can see like 21. It must be capital C. Analyze and synthesize again. Yeah, now it's complete. So it looks like now we have done everything correct. So in the next video, we're gonna create a test bench file to test this and see how it works.